Hello, my name is Kesini I'm from High School. Today I would like to talk about state tomography. Everyone would ever play the computer. How is the computer in the past? This is the first computer. Is it very big? But now we have the good quality of transistor. It make you have the computer is smaller than in the past. And what is the transistor? This is the transistor, and every year the number of transistor is increased, and until now we have the transistor is 1.4 billion transistor, and it is 22 nanometer, and they expect the transistor is 5 nanometer in 2022. But now we have the new technology that called quantum computer. It's worked by qubit. The qubit has two states in one state, but the classical computer is worked by bit that divide part of bit that 0 or 1. And the quantum computer has the new technology that I want to need study more. And how is the state tomography relate the quantum computer? If I want to learn about the qubit, I have to know about the procedure to experiment in quantum physics for quantum computer. The procedure in quantum computer make me know about the measurement in the state tomography. And if I know about state tomography, I will know the polarization of photon. This is the polarization state, and one I have the linear polarization and have H, V, D, and A. H is horizontal polarization, V is vertical polarization, D is the linear polarization at angle 45 degrees, and A is the linear polarization at 135 degrees. And I will show on density metric. And this is the circular polarization, have R and L. R is the right circular polarization and L is the left circular polarization. And this is the elliptical polarization. It can be shown on imaginary paths or density metric. Okay, and I have the optical equipment to test in the experiment. The one I have the polarizer. Polarizer is optical filter. And two, I have the polarized beam filter. It can be split to incident to two beams. And three, I have the half-wave plate. It can be support the linear polarized wave. And four, I have quarter wave plate. It can be the non-linear polarized wave. And five, we have the beam splitter, but it can be just split to beam. And six, we have the detector. This is the photon detector. It can be absent or present the single photon. Okay, this is the operator of polarizer, and we will show on density metric. This is the operator of polarization beam splitter. And this is the operator of half-wave plate and quarter-wave plate. Half-wave plate is shown on linear rotation if no imaginary involved, and quarter-wave plate is shown on the non-linear rotation. And this is the process. I have the density metric of input and pass the operator, and I will know output. This is the equation from this form. And example, if I have the input is the horizontal polarization and pass the half-wave plate 45 degree, and I will know the output is vertical polarization from this density metric, and this is shown on the density metric but in the output if laser is not pure state, laser is mixed state, and we will find the output from the measurement the photon, not find from this equation. Okay, this is the setup experiment. Setup experiment is we will find 1 qubit, and I have the source is laser and 5 form detector. Okay, this is the procedure. In the state tomography have 4 procedure, and I will divide part 1, part 2, part 3, and part 4. And part 1, we will find N0 from light. Light is part beam splitter and part process of 1/2. And part 2, we will find the N1 from the light and pass half-wave plate at angle 0 degree and pass beam splitter, pass polarization beam splitter. And we will use measure of horizontal polarization. And part 3, we will find the N2, and we have light to pass through the half-wave plate at angle 22.5 degrees and pass polarization beam splitter, and we will measure the polarization at angle 135 degrees. And part 4, we will find N3. I have light pass quarter wave plate minus 45 degree and pass polarization beam splitter, and I will measure the right circular polarization. Okay, if I know the procedure, after that I will know the number of photon, and this is the method to find the density metric. I have the stick is Ni. Ni is the number of photon. After that, I will find Si from this equation, and after that, I will know density metric from this equation. Okay, this is my result. We will record the data, both left and right side, and I record until the 1 and the dot to 20, that is called 20 times. Okay, this is the average on the number of photon, and after that I will find the S1, S2, S3, and S4 in the equation, and after that I will find the density metric from the equation, and I will show on the table. And this is the density metric on left side, and this is the density metric of right side. After that, we will put the data into the graph. If you see the graph, you can see the one data is the most variable that approaching 1, and another data is have the wall approaching 0. And in the imaging part, I see the left and right side is have the wall approaching 0. In conclusion, we can conclude the data in 1 qubit by we know the density metric of photon of single photon is this metric, and this is the ideal, but I know the density metric is vertical polarization. Okay, future work. Next step in experiment, we will find two qubit, and we will let the 2 qubit to test the quantum property is called quantum experiment. Thank you.